Hi, my name is Eric Chudler. I'm a neuroscientist at the University of Washington, and today I'm talking with Courtney Paschall, who is a MD PhD student at the University of Washington.
Hi, Eric. Thank you.
Well, what does it actually mean to be a PhD MD student? What's involved in that?
So it's a combined degree program that fits a PhD in the middle of med school. So med school is traditionally about 4 years long, and it's divided into an academic portion that's classroom based, and then a clinic portion that typically involves students spending 3 to 6 weeks with different specialists. For the MD PhD combined degree, they kind of split that 2 years and 2 years and fit a 4 year approximately PhD in the middle. My
So you're
program is also a part of the medical scientist training program with the NIH.
so your PhD will be in what department?
So I am with the bioengineering department, and my PhD focuses on neural engineering.
And have you taken all the medical school classes yet, or do you have to take bioengineering classes? Or do you take both? How does that actually work?
You take both, and there's a little bit of overlap if one, as an MD PhD student, picks a PhD that has a potential clinical application. So in my case, for the neural engineering focus, I did have to take neural engineering courses, statistics courses, and other preparatory courses, just like a normal graduate student. But I had some overlap from the 2 years of medical school surrounding neuroanatomy and neural functionality.
Mhm. Um, um, uh, Before you entered graduate school, what did you do as an undergraduate? Were you always interested in neuroscience or bioengineering?
So I have a bit of a windy path leading me to the MD PhD program. I started straight out of high school, went to the US Naval Academy, got a degree in applied physics with a language minor, became a pilot, left military service, wandered the globe a little bit, finding myself, figuring out what I wanted to do next, and decided that I knew I loved school. I loved the ability to learn something in a really hyper fast timeline, go from not knowing anything to knowing something in a quarter. And I'd had this question always about reality. I think it's what drew me to physics originally. Physics is one way of tackling the big question of existence. How do things work? Why are they? How are they? And in a way, neuroscience is another way of tackling that same question. Instead of asking, how is the physical world? Why and in what ways can we interact with it? Asking the question from the perspective of, well, how do I as a human experience and understand reality? And so that led me back to school to get a neuroscience degree. I picked up an electrical engineering minor and completed all of my pre-med courses in the same time. It was a professor actually during the second bachelor's degree who asked me if I was planning to apply to MD PhD programs, which was a brilliant moment in my life because I didn't know they existed. But I'd done all this prep work that looked, exactly aligned with an MD PhD path. So I applied MD PhD and ended up coming to Seattle to participate with the Center for Neurotechnology and this budding neural engineering focus that really not terribly many schools are part of. So I think I've always had an interest in kind of fundamental questions of curiosity, asking why from a young age. And I think that that absolutely translates to an early desire to understand how I as a human engage, and that's neuroscience.
Mhm. And it may be a little early for you to have made this decision, or maybe you have, but after you finish both your MD and your PhD, do you imagine yourself being a clinician? Do you imagine yourself being a researcher? Do you imagine somehow combining both of them together? What type of job do you think you'll be in once you finish the program?
So I acknowledge the saying, right? Humans plan and gods laugh. So we'll definitely see how it plays out. But the goal is to maintain this physician scientist dual career, so dual training into somehow blending the two. I'm fortunate to be in the lab of Dr. Jeffrey Ogerman, who is a practicing neurosurgeon, pediatric neurosurgeon in focus right now, who also is PI of a lab. That's an ideal future career in many ways. And I'm fortunate that neural engineering is becoming increasingly common in terms of therapies for various conditions. For a long time, over a decade, neurosurgeons have been implanting electrodes into deeper brain structures to treat motor disorders. These implants are becoming more understood and applied to mental illness treatment. So functional neurosurgery for depression, or maybe potentially schizophrenia at some point, when we start to understand the ways that these electrical stimulation, these implants, can modulate brain activity, I see an increasing application in the world of medicine. So that blended career, it looks like looking forward, should go kind of fairly hand in hand.
And is that the type of research that you're doing in Dr. Ojiman's lab, or what will your dissertation focus on?
Oh, that's a great question. So the lab spans a number of different implants, and there's so much from a research standpoint that one can ask about these implants. So early work of mine has focused on a novel type of directional deep brain stimulation. It's a directional electrode that changes the architecture of the probe itself. I have focused on understanding the way this new architecture records from deep brain structures, how that might help in identifying a biomarker of motor disorder, for the development of adaptive stimulation protocols. And what that means is, right now with these implants, it's kind of an on or off binary choice. The implant is stimulating and that's providing therapy, or it's off. We're hoping, and researchers already demonstrated, that if we can find a particular neural signals marker, we could maybe use that as a feedback for a modulating system. So when the brain is in this state, we stimulate this way. When it's in this state, we stimulate a different way. And perhaps in doing so, can minimize side effects of the implants from chronic stimulation, can increase the kind of utility period, although we're already capping a decade. So maybe increasing isn't as important as reducing total stimulation to the brain. So I've focused there. I am transitioning as of about, we'll say 9 months ago, to a brain-computer interface in VR development with electrocorticography and stereo EEG. And this is in a patient population that receives implants not for treatment therapeutic purposes, but for identification. This patient population undergoes brain surgery to have electrodes placed against the cortex, or again to deeper brain structures, to identify the origin of their seizures. They only receive the implants for about a week. And in that week, as researchers, we have the opportunity to engage with fully awake, behaving humans while recording or stimulating from these implanted electrodes. So my research, in terms of what the thesis will kind of promote, is across multiple modalities of brain recording and brain stimulation, but all with a therapeutic or clinical focus.
Yeah, I can see so many different applications for many, many different patient populations. So that's really, really exciting. Now, I know that you're also involved with some programs with some fellow students creating a new organization at the University of Washington, Neurotech. Can you tell me a little bit about that?
Yes, I'm very excited. So Neurotech is a new RSO, which is a student organization really focused on undergraduate engagement. We are a graduate-led RSO, so we're unique. And are transitioning from work that we had been doing previously with the Center for Neurotechnology. So the RSO, Neurotech, is NEUROTEC, stands for Neural Technology, Engineering, and Computation, and it represents the vibrant research community on campus for neural technology, computational neuroscience, and neural engineering. We currently are continuing the annual hackathon that had been held under the CNT's umbrella. We are launching a new neurotech hardware library, so we can loan, cutting edge, commercially available neural technology to undergraduates to facilitate their prototyping and development of new neurotech hardware or new applications of the hardware, while pairing graduate student oversight, which I think is this key component that the neurotech RSO can offer, is not just giving students hardware, but providing that mentorship, guidance, and research insight that graduate students of various degrees can contribute.
I can imagine how useful this is going to be for a number of students, getting them into this area, introducing them to a field of science that they may not have ever heard about. So best of luck with that. So when you're not working on neurotech, when you're not working on your medical studies, and you're not in the lab busy with your PhD studies, what do you like to do outside of all those things? What do you like to do in your spare time?
It's so, I love this question because the thought of spare time is so ambitious. In all honesty, the last probably 4 or 5 months has required that I learn C#, which is a programming language I had no familiarity with, in order to design really precise virtual reality experiments. So most of my free time in the past quarter has been dedicated to game design. So it's a little within the wheelhouse still of the research that I'm doing, but it's so rewarding and so fun. I remember I'm working in Unity, which is C#. I'm working in this Unity game engine, and day one, I'd never owned a VR headset. I'd never put one on before. And day one was setting up a VR headset and running my first Unity tutorial. And in 2 hours, I had gone from knowing nothing to building my first interactive virtual reality game. I love this world of game design. It is so engaging, and I still feel like such a beginner even 3 months in, which makes perfect sense. It's only 3 months, but my ambitions are way outscaling my current capacity. So I spend most of my time catching up to my goals.
Well, thank you very much for sharing. I'm glad you can spend a little bit of that free time with me this afternoon. So thank you very much, Courtnie.
Yes, thank you, Eric.
Yeah, bye.